and welcome to our next instalment of Python Live, powered by Amicus Recruitment. For those of you who don't know who Amicus Recruitment are, we specialize in recruiting across 3 key technologies, which include Python, obviously, Golang, and JavaScript. Now, my name is Jordan Hayward. I am a managing consultant over at Amicus Recruitment, and I specifically focus on recruiting across the Python market with a particular focus on the Austin area, but also remote opportunities across the US as well. So tonight I'm joined by the amazing Nathen Hinson, which by looking at the chat already is known to a lot of you as well. But yeah, obviously Nathen has worked for some top tech companies throughout his career, including Rackspace, GLG, Bewell, and recently has branched out on his own with a co-founder as well to found Concrete Engine, which is a young tech consultancy based out of Austin, I would assume, because that's where you're based, Nathen. And yeah, Nathen has kindly taken the time to put together a brilliant webinar on the topic of Python monoliths. As always, these webinars will be structured in the form of a Q&A. So if you do have any questions throughout, hopefully you have plenty, please stick them in the Q&A tab at the bottom of your screens. And Nathen, I think he's blocked out a few times throughout to answer questions, but he'll tackle them throughout and get through as many as he can throughout the webinar. So yeah, that's enough from me. So I think it's time to introduce and hand over to the main man himself, Nathen Hinson. Thanks for joining us.
Absolutely. Thanks very much for organizing this, Jordan. And
no worries.
Thanks to Amicus for doing the legwork on a nice bit of marketing there. Welcome, everybody. Thanks very much for coming in and checking out a talk on Python monoliths, specifically about solutions that you can entertain beyond simply maybe a perhaps rote statement of microservices. Just to get started, I don't know if any of you read the invite in any particular detail. There's a small blurb about sort of what this talk was going to be about. And I made mention of a few terms. And I wanted to define those terms before we really got into the meat of the presentation. And the big one for me, because this is really the focus, this is a topic that I'll be coming back to over and over again, is business value. And that's wonderfully vague. It's a tremendously vague statement. But for the purpose of this presentation and this little collective we have here, I'd like to define that and kind of boil it down to 2 key concepts, which is business value means you're either making money or you're saving money. And one of the reasons I'd like to kind of have that binary equation to these two, to the notion of business value, is because a lot of the operations that we as people in software, and it doesn't matter your role in this particular topic, if you have any role in software, almost any part of the software development lifecycle that you participate in, even recruiting, Jordan, really can be boiled down to, are you making money or are you saving money? Just a quick example of how software can make money. You have the old school style, right? Microsoft Windows. I'm going to build a piece of software, throw it in a box, put it on a shelf. I'm going to sell it like anything else. I'm going to sell it like a can of tomatoes. Saving money, that's a little more nuanced. Let's pretend that you work for a company that manufactures bathtubs, and your job is to optimize. You're a machine learning expert, and your job is to optimize how quickly the belt can roll through the enameler in the bathtub factory and still get a good coat of enamel on it. You're not making money there, but you are definitely potentially causing a savings of money because if you can make that belt go any faster, they can produce more bathtubs and hopefully sell more bathtubs. So I'm going to be boiling almost everything we talk about in this pitch back down to one of those two items: save money, make money. Falls under the heading of business value. The other definition I'd like to kind of get out of the way would be, what's a monolith? And I said Python monolith, so this means it's an application, it's a software monolith, it's not a geologic feature. And as any good person does when they go about creating a presentation, I went to the source of truth, which is Wikipedia, and looked at their definition. And they had this wonderful, long, wordy definition. But the part that stuck out to me the most was the sentence about a software application that is designed without modularity. It's a software application designed without modularity. Boom. How much simpler can it get than that? That's really what all of this, the whole definition boiled down to. So much so that that's what we're going to operate on. Right? So that's, for the purpose of this presentation, that's going to be our definition, is a software application designed without modularity. And the reason I want to call that out is because when you are performing analyses, it's important to understand the why of what you're doing. And in our case, what we've said for this presentation is the why is always going to be make money, save money. That's why. The why of everything is going to boil back down to that, which includes the why of why we're talking about Python monoliths. So, unfortunately, in the industry, this notion, this term, has a rather negative connotation. It's pejorative. It comes with this idea that you are somehow antique. You have constructed an antique application. You are following antique business software development practices. You are not keeping up with what is current in the industry. And interestingly, and several of the recruiters besides Jordan that I've spoken with can acknowledge this, is very many organizations determine the fact that they have a monolith as being an existential business threat, right, to their business value, right? This means that if they do not do something about their monolith, they will go out of business. And this is a pretty serious thing. They spend large sums of money to make sure that they don't have a monolith. So I want to kind of reset that, because I want to point out a few things about things that you may not be aware are monoliths. Don't know how many of you have children or are children or are users of an app called Clubhouse. Clubhouse is an app, phone-based app, which does audio chats, these little audio chats, extremely popular with kids, I'm told. I have not used it myself personally, but their backend is a big fat Python monolith. It's a Python Django app. Its actual monolith definition I'm unsure of, but it is a Python Django app, that I do know. One of the oldest Python Django applications, and it is a monolith that or at least it has been in the past, that I was aware of since 2017, we have Discuss. Discuss is commenting as a service. If you've been on any website that has a commenting system, that a lot of times that will be discussed. And in fact, in 2011, 75% of every website that used a third-party commenting service was using Discuss. So much so that they served 151 unique visitors, 151 million unique, 151, boy, wouldn't that be impressive, 151 million unique visitors every day in 2011. They're still going strong today. They were just sold to a company in 2017 for an undisclosed sum, so I don't know quite how much they made. They had a big model. Sentry.io. If you're in the software industry, you're probably familiar with this. They, at one point, they no longer have a Python monolith, but at one point they did migrate away from that. and they were just valued. They just made 5 raises over the past, I think, 7 or 8 years of over $281 million, which is not bad. And lastly, one of the more famous monoliths out there is the Linux kernel. The Linux kernel started life as a monolith. It has, over the years, added such modular features like modular probe. If you've ever used Linux or used the command mod probe, where modules that control device drivers can be loaded or unloaded from memory. It makes heavy use of a lot of shared objects, .so files. You've seen those strewn throughout Linux. So it is not quite a monolith any longer. However, when it was first constructed, it definitely was a monolith. So much so that the kernel wizards at the time, Andrew Tannenbaum and Richard Stallman, mocked Linus Torvalds a lot for his antique monolith kernel, which is pretty ironic considering nowadays the Linux kernel is over 20 million lines of code and is powering this presentation that we are watching all today, right now, and billions of other devices every second of every day. So I suppose as a monolith, it's done okay. Take a pause here for questions, Jordan. Anything?
The only one we've got at the moment is, why do you spell your name with an E from Nathen Hall?
Yeah.
But none relevant to the topic. So
okay, we'll keep going.
Yeah, definitely.
Okay, so going back to our definition of monolith, right? We're saying it is an application that is non-modular. When you're evaluating something as a monolith, and I want to take a brief back out here, you, whoever you are listening to this, are probably participating in some organization in some fashion. And it really does not matter. This is not a conversation just for engineering leadership, just for business leadership, or just for senior engineer, none of that. Anyone at any point in the organization should be able to perform these steps, this analysis that I'm about to describe, in order to boil a question of this thing that we're calling a monolith. Is it really an existential business threat? Is it really going to cause us to go out of business? And that's very important, because if you're working for an organization where they don't care about whether you save money or make money, I'd recommend that you reach out to Jordan, and I'm sure he can find you a place that really will care whether you make money or save money. So that being said, how do you determine whether your monolith is an existential threat to your business? Well, there's lots of ways. One of my favorite is a set of tooling that is very popular nowadays, which is called APM, Application Performance Monitoring. There are literally dozens of different monitoring solutions out there right now for applications. Every single one of them has a feature in it, which is called APM, Application Performance Monitoring. And the reason I like it so much is because it has a wonderful overview dashboard, very much like this. It'll tell you all kinds of wonderful statistics, like how many requests per second do we have? How long did each request take? How many errors are we getting? You know, all kinds of great stats. So by themselves, they don't tell you all that much. They won't tell you where to go look in your code to solve your problem. They won't tell you anything like that. But in terms of where to go look for an existential threat to your business process in your monolith, they're actually not half bad. Why? Because it's all on one page. It's a nice one-pager. And personally, in my consulting career and my career, I've gotten an awful lot of value out of these things just by looking at them. If your company does not have one, that's okay. You can do the same thing with more effort by just looking at logs. You know, all this data is typically consolidated from logs. Sometimes it's telemetry inside the application. Either that, or I'm sure that your company would not be adverse to paying for one of these things, and you can wire it in yourself. They're typically relatively easy to wire into your application, and you can start collecting this data. One of the big, I guess, themes, I would say, that folks can harp on with the monolith is performance. Well, you know, our monolith is too slow. That is why it's an existential. People are complaining, right? We can't serve requests fast enough. There's high latency, et cetera, et cetera, et cetera. So one of the first things you want to look at is your APM. Here we have a screenshot from an APM from a real world monolithic application. And we can see, this is right from my own research here. This particular application in a 2-hour period back in March served 11 million requests. It's pretty good. It's a pretty heavy duty application. In 2 hours, it's doing 11 million requests. And as you can see here from the APM, it's incredibly clear, even though I have admittedly circled in red the bits that I'd like to call out. Latency is actually quite good. We're under about 400 milliseconds, right? This is a Python monolith. So also anyone, by the way, who tells you Python is slow, no, not really. About 400 milliseconds, yeah, sure, that could be better, but it's not bad. It's perfectly within the threshold for acceptable performance. And then you ask the question of, okay, well, what is acceptable performance? And thankfully, we don't have to answer that question because other people already have. There's a gentleman named Jacob Nielsen, and he has been a blogger and a usability aficionado forever. Wrote a book back in '93 called Usability Engineering, and he actually established what his research showed was too slow. So here we have it. We have about 100 milliseconds, or 1/10 of a second, is the limit for having someone perceive your system as being instantaneous, right? So, okay, the app before was not instantaneous. 1 second is about the upper limit for someone's thought to be continuing in a process, right? So imagine using your banking application. If the app is responding within 1 second, you haven't gotten frustrated, you know, clicking on the account balance section because it is coming back within 1 second. Sometimes people put in interstitials or wait windows or all kinds of other things to show you that something is occurring that can be useful, but within 1 second, people are probably not going to complain. My own personal experience, I found that this number can go up to about 2 seconds without too many people complaining. And then here we have 10 seconds, which is the limit for keeping users' attention focused. Interestingly, this number, in my personal experience, is much less than 10 seconds. After about 5 or 6, people are going to feel something is broken and not want to respond. But here we have the answer, right? What is too slow? So when somebody says, well, my app is not performing, you can say, okay, these are our thresholds, and how much of the application is actually too slow. And you can measure that, right? Because what we're trying to do is actually measure that. And why is it too slow? Then, once you have that measured, you turn the performance problem into one of an error. Performance is a threshold. Anything exceeding that threshold, therefore, becomes an error, an application error, right? So now we can translate over to errors and handling errors. Jordan?
Questions? I've got a few.
All right.
So, first one, Nick Pereira. Maybe this will be covered later, but do you have examples of how modularity saves or makes money?
Yes, sort of. I have okay examples, and it will be covered later. Thank you, Nick.
Yeah, do you want me to move on? So the next one, will that will be, yeah. Okay,
yeah.
perfect.
It will be covered. That will be discussed later.
Right, perfect.
Hopefully he'll find the examples good.
Yeah. Well, Nick, if you have any further questions later on, stick them in the Q&A.
Yep.
But next question, Melton Ballon, how should we communicate the monolith to leadership within the framework of make, save money?
Well, with all of the things that I'm discussing. So what we're doing is we're walking through the sort of bare bones metrics, right? So metrics that you can obtain from the running of your application. Once you achieve all of those metrics, you can then, we're going to do a little napkin math and get some guesses on actual hardcore numbers of cash numbers, cash money numbers of what you can bring to leadership as the term of this is what your monolith is costing you or not.
Yep, perfect. I've got one more, or two more actually. One's just come in. Next one, Eric Dunham. Welcome, Eric. Good to have you on. He has asked, are there any packages /build/ deployment management tools you've had more success with over others when it comes to monoliths, e.g. pip tools, pipenv, poetry, PDM?
Short answer is no. That's a little outside of the scope of this because build is part of the SDLC, and it is an important part, but that's going to fit into a scope of, well, honestly, I mean, problems is going to fit into a scope of errors, like what we're about to talk about. Now, specifically, I'm going to concentrate on errors caused by feature engineering, but that certainly shouldn't limit, and that's actually a great point, which is infrastructure engineering is just as vital to this whole process and does include build problems. So I would say that if one runs into build problems, you lump them in there with errors.
Perfect. And then one final question from Awais Arshad. If the same time limit that was mentioned are achievable in Monolith, will it make a difference if the app is Monolith or MS, microservice, I assume?
So that is the whole purpose of this talk. So I would ask that question. If you still have that question at the end, I hope you don't. But if you do, ask it again, and then we'll go back with all the things we're about to discuss.
Right, I'll keep it up for now then, and I'll come back to you at the end with it.
Exactly. Let's hope he doesn't ask that question again. That means that I have not done a good job.
Perfect.
Okay.
Right, yeah, that's all for the questions. So I'll let you crack on.
Perfect. Okay, so errors. I'm going to harp on errors quite a bit because we've lumped performance in with errors, and we're going to look at errors as a metric for determining whether our monolith is an existential threat to our business. What is the business value of errors? Back to APM. Why? Because it's great. It tells us how many errors we get. Here we can see the same monolithic application, and they get, let's see, 2,000, sorry, it's a little small there, but they get 2,470 errors in a 2-hour period where they handled 11 million requests. So in this application's particular case, I'd say the error ratio, which is less than 0.5%, is pretty insignificant. And, this would be something where my recommendation would be anywhere you're looking at less than 10% errors, you're probably okay. Just kind of, that's not an existential threat. Some businesses like to trot out, a lot of folks in this industry like to trot out something called the Pareto principle, sometimes also called the 80-20 rule, where 80%, the statement is 80% of your value is achieved with only, or is the other way around? 80% of the value is achieved with only 20% of the effort, and the remaining 20% is achieved with 80% of the effort, or something like that. This is misused a lot, is misquoted, especially by people like me, and misquoted throughout business. And a lot of times people use that for error generally. Like, oh, well, we have less than 20% errors. That's probably not okay. 20% is probably not okay. Errors are also very easy to determine because other people in your organization will be pointing them out. You will be getting bug reports from users. That's kind of the worst case scenario. You'll be getting, you'll be getting error reports. Maybe you use Sentry. You'll be getting error reports there. You'll be seeing them in your APM. You'll be seeing them, and they're a number. And remember, we're after hard numbers here because we're after metrics, and we can measure, things we can measure. So if you have an error count from an error reporting system, a bug tracking system, whatever it is, you want to collect that. You want to collect every possible error that your system is generating in order to add to your metric count. So here, I'm going to give you just a quick example. Here's a screenshot from an error reporting system. Some of these, this is an error reporting system, by the way, but these people have used it and labeled it as enhancement, which isn't true. But let's pretend that you don't see the type there, but for the sake of argument, we have 1,138 errors, which is not extraordinary from other organizations that I've seen. I've seen worse, I've seen better, but it's, it's nice. That's why I picked this particular screenshot, was because it's a good average, right? 1138 is a pretty normal number of errors that a larger system would have running at any one particular time. So let's take 1138 as our base number, and let's try to figure out what it costs to fix a bug, right? Because that's what we're after. As some of the questions have pointed out, what we're after and what we're always after is the value, which is dollar value. So according to Built-in, which is a US-based business networking site, they ran a survey, and they said the current average price of a senior software engineer right now is $146,000. That is how much the senior software engineer takes home, but it is not how much an organization has to pay in order to keep that senior software engineer employed. By the way, SSWE is short for senior software engineer, and TCO is short for total cost of ownership. So if you notice the total cost of ownership to the org, it's a little bit higher. This includes benefits, bonus, and any taxes they have to pay. So this comes out to a total cost of ownership for your senior software engineer of 178,000. Take that divided by the number of hours that can be worked in a year with some vacation time. You get this wonderful dollar value of 92.70833 reporting. Nobody cares. And then we're going to napkin math out and say it takes 16 hours to fix a bug. Is that too long, too short? I don't know. It's taken me 10 minutes to fix a bug in my career, and it has taken me a week to fix a bug in my career, and everywhere in between. 16 hours. Remember, what we're trying to get here is napkin math. What we're trying to get here is a gauge, because what we're trying to do is gauge something very big and unknowable, at least with some metrics that are better than, well, it's not modular. It's like, yeah, it's not modular, but what does that mean? So if we were just to take a wild guess and say it's going to take a senior software engineer 2 days to fix 2 days with talking with people and doing emails and all the other stuff to fix a bug, that means the bug costs $1,472 for that software engineer to fix. Throws it over the wall to the software engineer and test. That's the SWET, total cost of ownership, which same Built-in ran their survey, which was 74 total comp plus the various expenses. Using the same napkin math, we come out, costs the software engineer and test $400 to test and retest, talk to the senior software engineer, etc. Get this thing ready to deploy. So before it is even deployed, it has cost us $1,872 to fix one of these bugs, probably on average. Maybe that's too high, maybe it's twice, so at least takes 8 hours. I don't really know. But again, what we're trying to do is not necessarily nail down the specific number. We're trying to get a gauge of big, small, right? We're always working in those kind of coarse ideas here. We're going to add in a little overhead to this guy for people like Scrum Masters, project managers, infrastructure folks. You know, this is a, you know, even though we have a monolith, we're a very advanced organization, let's say, and we have this great CI/CD pipeline. So heck, we don't even have administrators. We just deploy and boom, off it goes. That's fantastic. It's still going to cost monies for all those other folks to set up the infrastructure and do the project management and collect the bug that we decided to fix and manage it and all the other things. So we add up all those bugs, take the number, we get 2.3 million bucks. That seems big to fix all of the bugs, and it is. And the concern here is that errors are, what I want to try to do is emphasize errors are an existential threat to a monolith, right? If you notice that your system has a large number of errors, I would say 1,100 errors is a large number of errors. This is going to cost an awful lot to fix. Worse, this is doing neither of the things that you're paid to do. You are paid to either make money or save money. Fixing a mistake is doing neither of those things. Instead, you're costing the company, not you personally, but the organization is, the engineering organization is costing the company $2.3 million to effectively get back to square one, to start working on things. So errors are extremely bad, and you want to make sure that that number is very low. If it's not, then maybe engineering, you know, leadership or whoever said that they have a monolith, maybe, you know, maybe that is part of the problem. You know, you don't know the answer to that, but you do know it's costing money. Errors are costing money. Okay. Questions? Yeah,
we've got a couple.
Okay, go.
First thing, so I think that number seems incredibly high to fix a number of bugs, from my opinion, just from looking at it. But I hadn't broken it down like that as you did.
Yeah.
But yeah, Eric's come back with a couple of questions. So firstly,
yes.
What ideas or past strategies do you have about how to encourage a more monolithic approach to the business if one finds themselves surrounded by dozens of microservices that are in practice actually tightly coupled to each other?
Right. Yeah, that's the danger, right? You've made a monolith in the network. I would love to answer that question. There are ways of doing that, but that is, I'm sorry, but that is beyond the scope of this presentation. So I'm going one way and you're talking about going the other way, and that is incredibly valid. And honestly, maybe we can do a follow-up with, okay, you've made a service mesh, how do you get out of it? I would love to discuss that, but there just isn't time, so I apologize. I can't answer that question.
Eric's also commented.
There are ways of doing that. Yeah.
Yeah. Eric's comment is in the chat as well, saying no worries, thank you. So, but he does have another question.
Sure.
So, do you have any examples of cost to the business of maintaining the differences between microservices and monoliths, especially with regards to sliding, shared dependencies, duplicated tooling, and other non-dry things?
No. So dry is dangerous. That is another discussion. So what I recommend is what we are going to do is talk about some ways of measuring, some ways we can measure code, I guess, value, right? You could apply that to a microservice architecture, right? Because the code doesn't change. I mean, even if you break it across the network boundary, the code itself is still code. So what you could potentially do is take some of these and try to find a way of determining some dollar values of code that you have in your repository. And we're going to talk about some ways of doing that, and simply apply those those problems. Like, look, we've got all this dollar value code, it's worthless. You know, I've discovered this thing that's duplicated all over the place. And there's also some tooling that I'm working on right now to help do that, specifically with code analysis through a repository, a source code repository. Git is fantastic for that, by the way. And just doing a lot of analysis of, you know, what's the same. So yes, there are techniques. I can't go into any more detail, and I'm not, unfortunately, this presentation doesn't address those, but hopefully you can extrapolate. I trust that you can, because I happen to know Eric, so I know he can. So I know he can extrapolate and probably come up with something that will boil down to a dollar number.
Perfect. And that's the questions for this time around. So yeah,
okay.
Feel free to crack on.
Modularity. Okay. So here, the interesting part, what I loved about the definition, remember, of monolith was, it was about modularity, and Nick brought it up. It's like, hey, we're not talking about modularity. And that's true, because the point isn't, I wanted to pivot away from that, because the point isn't whether you have a monolith or not. If you've already discussed that, you're kind of already lost, because it's not about modularity. It's about your business value. Or is your monolith causing you to lose business value? That's the statement, which is it's an existential threat to the business. But the definition we found was all about modularity. It had nothing to do with performance or errors or any of the other things that can cause threats to the business. So now we get to modularity. Can modularity actually be a problem? Sure it can. You can produce, I'm going to back out a little bit and talk about Python here. There are two dependency tracking tools that what they do is they determine whether a module has been included inside another module that Python uses. One is called snake food. You can look them up. They're widely available. And the other one that I've used more recently, which I like a little better, is called PyDeps. It's PyDeps. They both produce a graph that looks something like this. Now this looks like something a cat coughed up. And what you're seeing here is every line represents an import in a Python module from one module to another. Every little point that you see there, which are kind of invisible because there's so many of them, represents a single module, and all of the lines are interconnecting them. And you can see this is an absolute disaster area of a graph. And this is where, just a quick side note, I did work for an organization where a graph just like this was presented to the board of directors of the entire company, and they decided the application that produced this graph was worthless and needed to be canned. So do not underestimate the power that a dependency graph can have in its visual impact. As a development tool that is trying to disentangle a highly coupled application, they're not that useful, but I do recommend running it, because you can see it's like, okay, do we have a modularity problem? The question is, the answer is obviously yes. We have a terrible coupling problem. The system is not modular at all. It's one big mess. A new technique, because of the somewhat lack of specificity. Remember, I just said the dependency graph is great to show people because it can be visually appealing. But as far as an actual metric, to get back to our point of like, okay, what's the dollars here? It's not going to help you that much unless you count up. You could assign dollar values to each of the connections maybe, and try something like that. I'm not saying that's wrong, because there's no wrong answer here. What you're trying to do is determine how bad things are in terms that a business person can understand, which is dollars and cents. The other technique that I've decided to use, and this is the one that I mentioned before, which was to look at the merges to master or main of work in an organization. And you take those change sets, that is how many files needed to be touched in order for something to be complete, meaning that it merged to, main, master, whatever, it doesn't have to be main or master. Obviously, whatever branch is going into production, that's the one you inspect. And you inspect it for these commits. And what you do is you simply count up how many files have to be touched. If that number is large, I've seen it as high as 50, 60. And this is an average, remember. This is across the repository I was looking at was 80,000 commits. There were 50, 60 touches on every single commit. This was especially bad. That's an awful lot of stuff to do. So you could argue, it's like, okay, well, if we're having that many files that are touched occur on these commits, that's a problem. That's going to take a developer a long time. And the question of how long can be answered by your issue tracking system, right? You have some system, Trello, Jira, doesn't matter what it is, for tracking stories. And if you have a diligent Scrum Master or a diligent software process, you probably have some notion of velocity. And you can perform the same steps that we just talked about with regard to, we did the little napkin math with fixing a bug. You can do the same thing here, right? Because your velocity is going to determine how much each story costs. And you can just throw it in there. Now, I know that a lot of engineers have some gag reflex on doing that, because I have run across organizations where they want to use it as a developer productivity apparatus, and I have always discouraged that, because that's not what it is. I mean, this is napkin math. That's what you have management for. That's what you have reviews for. That is not what this is. And if an organization starts moving in that direction, I would again recommend you see Jordan. So that being said, again, perform the same math that you did before, number of hours, etc. You can get an actual average number of, like, how much did this cost? How much did all these stories cost? How much did it cost to make that commit in all of that time? And especially because remember, what we're after here is this thing that we're all building an existential threat to the business. So this isn't just about one person. This is about your whole team, right? You count all of those costs in. I just made up a number for like $300 for the folks who weren't engineering. But if you're doing this analysis, by all means, add in everybody, because anyone who touches that thing, no matter in what capacity, that's a cost that the business is bearing, and that reflects into the system that they're doing. So, questions? Last section here. We're almost done.
Yeah, we've got a couple coming.
Okay.
So one from Aaron Levenstein. If you are listing performance issues as errors, then the bug to error ratio would not be 1-to-1. Would that affect the monetary value you calculated for fixing errors?
Nope, I'm counting bugs as errors. You just add them right in there. They're an error.
Yeah.
Simple. That's why I like it.
Yeah.
Super simple.
Perfect. Happy days. And then another from Eric. How does the repository change set metric hold up alongside files with thousands of lines with functions or classes that are each hundreds of lines?
So your mileage may vary there. If you find yourself, so this is another analysis that you can do. Get an average count get an average of the line counts of all the files. So if you find yourself with code that it is instead of being file heavy, it is instead line heavy, then simply switch the metric, right? Turn the metric into the numbers of additions and deletions rather than the number of, so count additions and deletions in the commit instead of just raw number of files. What you're looking for is volume of change set. Are the change sets big? In order to get something done, does a lot of stuff have to change? That's what you're after. Not necessarily is it the files or is it the lines of code, is this how much stuff is in there, right? So absolutely, by all means, swap that out for, instead of file count, do it line count.
Yeah, perfect. There was just a question at the end of that one as well. What would you encourage as a complementary metric?
Yeah, line count.
Yeah.
Sure.
Okay.
Yeah, just straight up line count. I actually, just a quick aside, I'm working currently, Concrete Engine is working on a brand spanking, interesting code complexity metrics have not changed since 1975. The best that has come out was something Microsoft did in the 90s. Just nobody really just talks about this very much. I mean, nobody thinks about, I mean, I should say talks about, they talk about it, but they don't think about it very much. So we're working on a new code complexity metric that I'm hoping to come out with that can somehow tease out some of the detail in, it's a big fat, it's a big fat file with a lot of lines, but it's just a big data structure, for example, right? I've got to go in and change all of this stuff. Is it actually code? No, it's no logic. There's no branches. There's none of that. But it's like, I got to go change it. So what effect does that have? In antique code complexity, they would say 0. That took you 0 time, Nathen. That change cost 0. And it's like, no, that change took a long time. So we're really trying to work with that, get a little more granularity. Until you get there, just come up, kind of make it up, right? Is my rule of thumb. Best guess, because best guess is better than, well, I don't know, we should just do it.
Perfect. A couple more. One
Yeah.
from Awais. Does the number of changes frequency also matter?
Well, I mean, that's going to affect your average. So yes. I mean, what you're looking for is, how big are the change sets? If the frequency is, I mean, if you're merging a lot, yeah, I mean, your change sets are going to be more. So again, what you're going to present is an average. So yes, the frequency would matter there.
Perfect. And then one final one, and then we'll move on to the final section.
Yep.
This comes from Bernard. In the mesh graph you showed, is that measuring code dependency via imports or cross communication, or both?
Just imports.
Just imports.
Just imports. PyDeps and just for the Pythonistas, PyDeps and Snakefood both inspect something called the AST, the abstract syntax tree, and that's how they generate those graphs. FYI.
Perfect. And that's that's it for questions this time around.
Beautiful. Okay, some solutions. These may not be satisfying, I warn you right now. Things that you can do with your monoliths. If you have a performance problem, vertically scale. Throw money at the problem. As some of the audience may be aware, I had great success with this at one of my companies. We just threw money at the problem, and the problem went away. It really works great. Take 16 gig, make it 64. I can't stress how this really can help, especially, and this is something that the APM will tell you. APM will tell you, it's like, look, you've got a problem. Because the other thing is, a lot of these APMs, like I know New Relic, for example, does this, where they will actually tell you how much time you're spending in the database. They can examine your database queries even and tell you things, all kinds of things, so you don't even have to look at the database. It'll just tell you. It's like, oh yeah, by the way, you've got a performance problem there. And a lot of times, just giving the database extra oomph can help. So just to give you an example, probably the notoriously worst performing database in the universe, MySQL, still, when tuned properly, has been clocked by the folks that produce it at 1.8 million transactions per second, 1.8 million TPS. So I don't know what kind of site you're running, but I think that's probably going to be pretty good. And if you can't get that, if you can't get down to those numbers, that's a different problem that a microservice is not going to help you with. So, vertical scaling, I think, is a great solution for a monolithic problem. Horizontal scaling. To be honest with you, Python monoliths are pretty nice this way. I think if you were running something a little heavier, maybe something where developers didn't have the interpreter didn't do so much for them. The runtime didn't do so much for them, where they had to do more for themselves. There's more chance of making mistakes. This might not work so well, but with every single Python monolith I've found, horizontal scaling works great. So what that means is simply add more compute, add more nodes, and a lot of problems just go away. Add more memory to the node. You know, maybe it's a memory problem. Again, that's something you can very easily determine from APM. Or, you know, if you're using Kubernetes, you're going to get errors where, you know, pods are going to be constantly cycling through. It should be relatively straightforward to analyze that problem and say, okay, you know, we have a resource problem. Just to give another example, one of the larger monoliths that I looked at had a runtime that was weighed in about 600-700 meg. Would peak up when it really got going with a lot of requests before it got cleaned up at about 1.2 gig. So even with that, that's not a giant, you know, that is certainly not a giant instance, and just make more. It does work remarkably well along with the vertical scale. And this is the one where I wish I had better advice for you, but this goes back to Eric's question, library modularization. So if you remember, I mentioned the Linux kernel and Clubhouse. They do a lot of this, which is to say you're living in the same runtime, the same interpreter space, same memory space, but instead you have your modularization through, instead of having it through, as a microservice would suggest, you create a network boundary between your various services. You instead rely on it through just straight up imports. As the snake food graph showed, that can go bad very, very quickly, and you can get very, very bad. This requires a rather stringent amount of discipline from the engineering team, and to be frank, your team may not be up to the task. And if they're not, well, you could reach out to Jordan to find people that are, but you know, if they're not, then maybe you need to explore another opportunity. And of course, if all else fails, you can, you know, go back to creating a microservice, right? And just, you know, say, okay, this threat that we have seen in the form of modularization is so bad that we actually need to create a microservice. Or as another instance, another example, I ran into a team that actually didn't know anything about all the knowledge of the application left the building. They all left. They went and got other jobs. In which case the people left didn't even know Python. They didn't know how the application worked. They didn't know anything about it. And in that case, yeah, I was like, okay, write a microservice, you know, because it wouldn't help them to do any of these techniques because they couldn't. They didn't have the skill set to. So a rewrite was worth it. You know, how much does that cost? Again, go back to your story, napkin math. You know, get your velocity going, put some napkin math together and say, this is how much it's going to cost us to write these microservices. Understanding again, microservices probably aren't making you or saving you any money. And as far as the cost of modularization versus non-modularization, which I said is, I didn't have a satisfactory answer to, that's one that I'm diligently working on. I want to have a satisfactory answer to, because I don't, and I apologize for that. I don't have a great answer for how to turn that into a cash number, but that has to do with code complexity, and we're working on that right now, even as we speak. Just as a parting note, I love this video from Krazam about microservices. I think it is so accurate as to how they can go wrong that it is actually architectural guidance. And I recommend you all Google it. I've even Googled it for you here and give it a watch. And I'd like to again thank you all. I hope that you have found some value in this. I hope that you can take something back to your org, maybe think about it a little differently, and make friends with those folks in the business office. talk to them about making money or saving money. Thanks very much, everyone.
Perfect. Yeah, that's the end of the presentation. So just like to say a massive thank you, Nathen, for putting that together. I think I was just checking the Q&A. I think we've got one more that's literally just come in. One final question from Eric. Well, no, we've got two more. So they're coming in now. So if anyone wants to ask any more questions, get them stuck in this Q&A tab now, and we can quickly rattle a few off. But first one from Eric. Have you heard of a defined business value or impetus for modularity, i.e. why is it always a good thing, in brackets, I mean, not to me necessarily.
Right, yeah. Oh, I totally get it. That's a good question, right? So it's funny because when I made a couple of these presentations, by the way, and I could easily drift off into tangents. And that was one of them, which is, all right, let's talk about modularity, right? And in that, that can get very sticky because a lot of times engineering organizations will find themselves modularizing across things that aren't domain specific, right? They say, oh, well, our app does a lot of math. We're going to have this whole module that does nothing but determine the distance between 2 points, or determine this distance or that's this. I have this entire module full of distance calculations, right? And they're like, oh, that's a good one because distance, that's conceptually the same, right? And if you think about it in engineering fashion, it's conceptually the same. But then you find, well, you're doing a fitness app and that sucker needs to be included everywhere. And all of a sudden now you're not modular anymore because you, instead of modularizing around, you chose a module distinction and didn't determine a module distinction with the business, right? I mean, you weren't paying attention to what your business was changing. You weren't paying attention to what you saw in your GitHub commits about what's changing together, and instead just made a call, based on relatively arbitrary statement of math is the same. So in that, the short answer is no, I don't, but I'm working on that very thing because, to be frank, this is, again, as I've said, an extremely unstudied part of our business of software engineering, the actual cost of these things. A lot of work has been done, but it is literally 40 years old.
Perfect. And then we've got one final question from Melton. When will you release the app?
Oh, tooling. Well, I don't know. That remains to be seen. I'm on LinkedIn. You can find me on LinkedIn. As I will post it widely on social media when I have something to share, because I do want to share it, not because I care about me, but I want people to have these discussions because it's going to be it's going to make my job a lot nicer, right? You don't have to battle questions of, well, we're going to do this microservice thing because just yes, and it's like, yeah, let's talk about, let's actually come down to some metrics. And so I really want to get these things out. I promise I will as soon as I can. I'd love to start publishing some stuff on complexity analysis, to Eric's point, which is, digging into that. I said my answer on modularity wasn't that satisfactory. I admit that, but I do want to work on that and try to get a satisfactory answer on that, so we can have a way of, dealing with these questions in a concrete fashion that we can all agree on.
Perfect. Well, happy days. Well, that wraps up today's webinar. So again, a massive thank you to you, Nathen. It's always can be a bit of an effort taking the time to invest, putting together a webinar and a presentation. So I really do appreciate you taking the time to do so, and then for giving such a good presentation as well. I'm confident that everyone's probably taking something away from today's event. Also, everyone that attended, thank you very much. I know it's not always to take an hour out of your day to attend these sorts of webinars and events, so really do appreciate you coming today, and for all the questions that came flooding in. Love it when there's a lot of engagement. I think it adds a good dimension to the webinar itself. As I've mentioned before, today's webinar will be recorded. It will be published on our LinkedIn channels. It will be published on our YouTube channel as well. So if you did miss any of it or just want to rewatch it, feel free to do so. And as ever, if you have enjoyed today's webinar, please do subscribe and follow us on our LinkedIn page, which is Amicus Recruitment, our events page, which is the live series, and our YouTube channel, which is Amicus Recruitment again. We've always got new webinars happening week on week, so you'll be regularly notified through those channels. And yeah, again, massive thank you to everyone, but massive thank you to you as well, Nathen. It'll be great to have you on board again soon. And yeah, looking forward to it.
Absolutely.
Perfect.
Thanks so much. I'll come back anytime, Jordan.
Perfect. Well, thank you very much. Really appreciate it, and enjoy the rest of your days.
We appreciate it.
Thank
Thanks, everybody.
you. Cheers.
Bye-bye.
Bye.
Good night.